Here's a triangle. Which side is the longest and by how much? Guess before I tell you. If you've seen a right triangle before, you know the shortcut. 3 squared plus 4 squared equals something squared. That something is 5. 9 plus 16 is 25, and the square root of 25 is 5. A 2 plus b2 equals c2. But here's what's cooler. That formula doesn't just live on triangles. It's a way to measure distance through any number of dimensions. Say I've got 2 points on a flat plane and I want the straight line distance between them. I can make a right triangle out of thin air. The horizontal leg is the difference in x coordinates. 4 minus 1 is 3. The vertical leg is the difference in y. 5 minus 1 is 4. Look familiar? It's the exact same 3 to 4 to 5 triangle, just tilted and floating in space. I find that distance c the same way, square root delta x2 plus delta y2. This is the 2D distance formula. It's just Pythagoras with nicer clothes and be replaced by the change in x and the change in y. Now what happens if I add a third point straight up in the air? Guess the pattern before we zoom out. I'm measuring the distance from point A to this floating point C. No triangle yet, I have to build one. First I find the distance on the floor. That's the 2D distance we just did from A to B. We already know that's 5. Now look at that vertical line from B up to C. That's the change in Z. 6 minus 1 is 5. A new right triangle, just not on the original axis. Its legs are that floor distance and this vertical height. Its hypotenuse is the actual distance through space. 5 squared plus 5 squared equals the diagonal squared. 25 plus 25 is 50. The square root of 50 is about 7.07. I used the Pythagorean theorem inside the Pythagorean theorem. The 2D distance was a hypotenuse, then it became a leg for the 3D hypotenuse. Stick the 2D formula inside this new step and you get one beautiful equation. D equals the square root of delta x2 plus delta y2 plus delta is2. There's no new rule for 3D. I didn't switch formulas. I stacked the same idea on top of itself. And this stacking doesn't care if we stop at 3. A mystery fourth dimension, call it W, would give you delta x2 plus delta y2 plus delta is2 plus delta 2 all under the root. No new geometry to memorize, no fancy tricks. Every new dimension is just another perpendicular line, another leg to square, another term in the sum. When a formula works the same way in 100 dimensions as it does on notebook paper, you've tripped over something real, not a human invention, a pattern that was waiting to be noticed. Next time you see a diagonal on a computer screen across a room in a video game coordinate, you're watching that same right triangle do its work. It's all the same at 2 plus b2. What's a math pattern you notice that shows up where you didn't expect it? Drop it in the comments. I read those and genuinely want to know what clicks for you.